Now I'd like to acquaint you with the USB flash drive demo LabVIEW project. Look on the top of myRIO and you'll find the USB port. I'm going to begin with nothing inserted into the USB port. Now here's the demo VI. It can display some information about the flash drive that's inserted. However, with nothing inserted, you'll see this error message. It says file not found, and especially we see that there is nothing in the flash drive directory, which is /u. Now let's take a quick look at the myRIO file system. I'm going to open a browser and then browse to the IP address of myRIO when it's connected by the USB cable. Add /files to the IP address to see the file system. Log in as admin. And here we see an index of all of the files on the myRIO file system. In particular, down here I notice the absence of the /u directory. I'll go ahead and insert my flash drive and then press F5 to refresh the browser display. Here we see the U folder. I have 2 files at the moment on the flash drive, and I also have an empty folder listed. These are text files, and you can click them and see the contents of the text file. All right, back to the VI. Run it this time, and now we see that the 2 files are listed, and it also has detected the folder name. All right, let's move on to collecting some data. If you move the myRIO around, that will activate the accelerometer, and you can start to see the value change on the x-axis. Here's the name of my log file. The full name is listed there, and when you hit stop, it shows a complete record of all of the data that you collected. In this case, almost 24 seconds worth of accelerometer data. Come back to the browser for a moment, press F5 to refresh, and there we see the comma-separated values spreadsheet file that has been created by the VI. You can go ahead and open that directly. We have 2 columns worth of data. Let me do a scatter chart here. Plot the B column versus the A column, and we recognize the same waveform graph that we had in the LabVIEW VI itself. All right, let's return to the VI and start to take a look at the details of the block diagram. I have a file constant here to define the USB flash drive folder, and that's /u. Here's get file info and list folder. These are available under the file IO subpalette. File constants, this is where I have the path constant for the USB flash drive. Under advanced file functions, you can find get file info, and here we have list folder. At some point, I encourage you to take the time to study all of the available VIs that you have for working with the file system. To get a better idea of get volume info, let me turn on context help. And this says that we get the number of bytes in the volume and then the number of available or free bytes in the volume. I'm taking those values and dividing each by 2 raised to the 20th power, and that converts the number of bytes into the number of megabytes. The logical shift with the argument of -20 amounts to moving the binary radix point 20 places to the left. Here we have the formatting string. The %d values are placeholders for decimal values that get inserted into the format into string output. Next, let's take a look at displaying the contents of the top level folder, and this is with the list folder VI. This produces a pair of string arrays, one for file names and one for folder names. Now let's take a look at the data logging portion of the VI. We're collecting information from the onboard accelerometer and then saving that to an Excel spreadsheet. Following the propagating error cluster, we ensure that we do the details of the USB file folder first and then go into this timed loop. Look under the myRIO palette, and then for onboard devices we have the accelerometer. I have only the x-axis enabled. Every time we read the accelerometer we get a single value, and that's reported on the display right here. So we see that one updating in real time. Then I'm collecting these values from the accelerometer into an array. Use the indexing mode on that tunnel. In a similar fashion, I also capture the loop index for each one of these samples and also turn that into an array. That process will run until you press the escape button. Once that's pressed, you break out of the timed loop, and then we have two arrays, one for the data, one for the time. And here I've converted the array from the loop index values into time in seconds. And I can do that by knowing that I'm using a 10 millisecond loop time. Bundle those two arrays together into a cluster, and that becomes the basis for the waveform chart down here. Now let's take a look at saving this away to a spreadsheet file. I'll begin with this constant which specifies the USB folder, then use build path to assemble the log file base name, the absolute folder, which is /u, and the .csv extension. These are concatenated together into a string. Concatenate string is located right here. And finally we can see the complete log file name right here, /u/logfile.csv. Note that you must use absolute file paths on the myRIO real-time target. Here's the write to spreadsheet VI. It takes either a 1D or a 2D array. In this case I'm using a two-dimensional array. Build array is located right here, by the way. And we want to save to comma separated values. That means the delimiter needs to be changed from its default of a tab to a comma. Also, I'm going to set the transpose operation to true, and that will print out the values column-wise in the spreadsheet. Finally, we end up with the simple error handler that's located here under the dialog and user interface subpalette. I'm going to finish here by removing the flash drive from myRIO, inserting it into the PC. Do a quick view of the folder contents here, and the log file created on the myRIO is now ready for transfer to the PC.